This is The Red Line, where we interview three geopolitical experts on one big issue shaping the news both here and overseas. I'm your host, Michael Hilliard. Just a little over 3.5 years ago, we released episode 37 of this show, The Geopolitics of Rare Earths, with the episode warning about the Chinese domination of the current supply chain, the importance of these minerals to our national security, and how China had managed to work its way into a position where they control 90 to 100% of certain elements and parts of the rare earth supply chain that, not coincidentally, are some of the same exact parts of the supply chain that the United States relies on to build its newest generation of missiles, the F-35, and the latest supercomputers. But that was 3 years ago. And since then, I'm happy to say, there have been so many announcements about rare earths. In fact, during these 3 years, I've seen dozens of announcements of joint supply chains and friendshoring. I've seen announcements from countries all around the globe touting massive new rare earth discoveries. I've seen the unveiling of massive flashy government programs. And I've seen just so many politicians in hard hats announcing that this new mine opening here will be the solution to the problem. And throughout that entire time, me personally, I felt like I'm watching the captain of the Titanic give his speech about how unsinkable the ship is. Because whilst all of this has been going on, and all of these programs continue to spend more and more on the very bow of the ship, the people watching closely noticed that almost nothing was being done to the other 3/4 of it. In other words, what we do once we get that dirt out of the ground. And whilst I sat at conferences hearing nothing but positive news about the industry, there were far fewer people looking into the increasing restrictions that China was placing on its rare earth refining technology, or even the fact that China just merged 3 of its largest rare earth companies into one Chinese super company, all to make sure that the Chinese central state could maintain an even tighter grip on the global supply. So how on earth did we actually end up in this position? What are the underlying issues that still exist now like they did 3 years ago? And now that dozens of these governments have announced their official plans on how they plan to tackle the issue, what does the roadmap for the public and private sector look like going forward? Well, those are just some of the questions we're going to be covering here today. And to take us through how we find ourselves in the position we are, we turn to our first guest.
Part 1. Monopolizing minerals.
Finding a deposit that has a large enough concentration is limited by geology and the forces of the earth as they produce these deposits over time. And certain countries hit the jackpot and get lucky, and others do not.
Fabian Villalobos is an engineer and a professor of policy analysis at the RAND Corporation, with his work specializing in the intersection of technology, economics, and geopolitics, and its impact on national security and homeland defense. Fabian also has a background in materials science and chemical engineering with an emphasis on aerospace materials, critical minerals, and energy storage, and is the co-inventor and co-author of several key patents. So we're thrilled to have him on the program today.
Finding something that's economically viable, but also has a large enough deposit to mine it over a long period of time is something of a rarity.
So back in February 2021, we did an entire piece on rare earths and the problems within the industry, as well as the basics of how everything works. So obviously you can go back and check out that piece, and that'll give you a more in-depth run of the basics of everything. As today, we're mostly looking at the advanced problems and the developments in the industry since then. But just in case you don't have time to do that, let's just go over some key notes and take you through what you really should know going into this. Now, if you aren't aware, rare earth elements, or REEs, are a group of 17 elements, with 15 of them being lanthanides and the other 2 being scandium and yttrium. And although we call them rare earths, they actually aren't even that rare, because you actually find deposits of these things almost everywhere in the world. So why are they called rare earths then? Well, the thing is, when you extract rare earths from the ground, they're so diluted in the Earth's crust that it's the concentrations that are actually pretty rare. So I'll give you an example here and explain it a bit more. I want you to imagine for a moment that I plonk a big bucket right there in front of you. And that bucket is full of M&Ms and Skittles mixed together, which is an absolutely awful thought. Now, in the analogy here, the M&Ms would be the waste dirt, the stuff you just pull out of the ground, and the Skittles been the useful materials we're looking for. Now, if I go back to that bucket, and I tell you that I'll pay you $5 for every Skittle you bring me, but you have to sort through them all and extract those Skittles out of the bucket, with that bucket being a representation of a rough ton of dirt we've just pulled out of the ground. Now, for a mineral like copper or iron, we might expect to find something like a kilo of pure iron for every ton of dirt. So if our bucket had 1 million M&Ms inside of it, we could roughly expect to pull about 1,000 Skittles out of it. And here's where the concentration comes into play, because if we're looking at rare earths, if I buy that same size bucket with 1 million M&Ms inside, I would probably only expect to get 1 Skittle out of that entire bucket, with that Skittle being not only harder to find, but also saddled with these same costs to transport that bucket, get it into the refinery, sort through it, and find those Skittles. As regardless if I'm pulling out a kilo of iron or a gram of neodymium, it still starts the same ton of dirt, high costs, and all I get for it is 1 lousy Skittle. And this is why we characterize it as rare earths, because although they're everywhere in tiny amounts. So then why all the fuss? Well, frankly, these rare earths are absolutely amazing at a whole range of jobs, because they have absolutely unique chemical and physical properties. In fact, pretty much everything in high-end technology will require at least some amount of rare earths. For example, your phone is very likely to have neodymium somewhere in it. And whilst we could talk about the consumer market here, I want to move for just a minute to defense, because rare earths are particularly important when it comes to new warfighting technologies. To which, as an example, to manufacture a US F-35 actually requires approximately 420 kilograms of rare earths, which again, you can see how things begin to become very expensive. And you can quickly see why it's the Department of Defense that really worries A, if we have access to rare earths, and B, where those rare earths come from. And here's where I really need to talk about the production chain as well before we really get into things, as just getting the dirt out of the ground is really only a very small part of the story here. Now, REE production is actually more complicated than most standard mineral extraction is. Now, on top of there being incredibly low concentrations of this stuff, REE production is actually far more complicated than most other minerals and requires a set of key steps for each part of the process. So for a minute, let's go back to our bucket of M&Ms and Skittles. Now, the start of this process is known as extraction. Now, extraction is getting the dirt out of the ground and beginning to separate it. This would be you heading down to my warehouse where I have a giant pile of M&Ms and Skittles mixed in together, effectively the mine site, and you going up to that pile and filling the bucket with what's there. Now, this part of the process here is fairly straightforward, but from there we'd move to the next stage, which is refining, effectively trying to get the mineral down to a fairly pure form. Now, sticking with our analogy, refining would involve you picking up that bucket of M&Ms mix and taking it back to your apartment, and then either using chemicals or machines to try and find those Skittles. And this is where a company will be trying to get a big pile of dirt to a concentrated mineral. Now, once it is concentrated in a mineral, and you have your 99.9% pure neodymium bar here, in other words, you have a bowl of pure Skittles, the refiner can then sell that onto the market, to which companies can then buy the pure element. But what some countries do is move it into the next stage of the process, which, forever simplifying, we're going to call component creation. This is effectively where we take this pure neodymium and make it into a magnet, or make it into missile parts, or make it into triggers. In other words, for our analogy, take that bowl of Skittles and make it into a gingerbread house or an artistic design, just something that would be worth more than what the Skittles would be by themselves. And that's the 4 parts of the chain we're going to be talking about today. There's the mining and extraction, which is effectively getting the dirt out of the ground, or in our analogy, heading down to the warehouse to fill our bucket with the M&M mix. Refining, which is effectively taking it from that big bucket of M&Ms down to a pure bowl of Skittles. And component creation, which is effectively making those Skittles into a gingerbread house, so we can sell it on for more money. Again, poor analogy, but it's also nearly lunch as I'm recording this. But Fabian, can you take us through one of the biggest factors that drives this and talk a little bit about the costs? How do these costs here compare to, let's say, getting iron or copper out of dirt?
It's pretty difficult to put a price tag on there simply because there's not a lot of clarity on what the actual real price of manufacturing these is. Because a lot of this refining is done within China and specifically in Chinese state-owned enterprises, that includes a lot of subsidies, that includes a lot of tax breaks, it includes a lot of structural incentives to keep this processing capability within country. It's pretty difficult to even just to put a price tag on the different processing steps.
So now if we go back to that chain again, let's first take a look at the extraction stage. In our analogy, filling the bucket full of the M&M mix. Now, China used to absolutely dominate this part of the chain, having at one stage between 90 and 95% control of the market. But that wasn't until recently, as particularly in the last few years, we've seen some pretty serious effort into trying to divest this industry away from China. But it's not like we just learned that rare earths are important. It's more that in the past, China exploited a pretty obvious flaw in our extraction system and leveraged that into absolute control of the industry. Now, for some backstory here, before the 80s and 90s, the rare earth market used to look a lot like most of the minerals, with countries like the United States, Australia, the USSR, all being fairly large players within the market. In fact, the Americans used to even have a very large mine out in Mountain Pass, California, but that was until China chose to weaponize the industry and use the West's free market to frankly destroy Western production. See, the Chinese were able to do this because frankly, the Chinese companies that Beijing put in charge of it didn't actually need to make money, as all of them were either partly or completely backed by the Chinese state. So whilst these American mines had to pay higher wages, higher costs, and also have to pay a profit to their shareholders, the Chinese ones were more than happy to sell it at below market cost. And with a kilo of neodymium being exactly the same whether it comes from China or the United States, the market responded exactly as it usually does and simply went where things were cheaper, which was China. And what would happen very quickly is that none of the Western firms or mines had any hope of being able to compete with China in the market. So across the 80s and 90s, almost all of the rare earth mines outside of China simply shut doors. What China had done is lower the cost to below what everyone's break-even was, bankrupted all the Western companies, pushed them out of the market, before then raising the prices once they had complete control over it. Not only starting to make money, but also having almost the entire industry to themselves, which again at the time a lot of people seemed comfortable living with. Until a few years later, where tensions between China and Japan reached a boiling point over the Ryukyu Islands, and China decided to temporarily cut off Japan's access to rare earths. This incident, more than almost anything else, was a massive warning shot across the bow for everyone, demonstrating to the world that China could and had weaponized the rare earth industry. And it was at that point that Washington had a pretty nasty realization that their new F-35 fighter, which requires 420 kilograms of rare earths to make, might have a problem in their production chain if they have to ask China for the minerals to make it. And so, in recent years, rare earths has become a national security priority for the United States, Australia, Japan, the EU, and a whole bunch of other players. And particularly in the last 2 years, it's been the Biden administration has been making big pushes to try and bring rare earth mining back to the United States, or at least United States allies, making some pretty meaningful pushes, like starting up a domestic refinery in Texas, with the Linus facility in Texas due to become operational somewhere between 2025 and 2026. However, that raises a question, as this refinery only got off the ground through a massive injection of cash by the US Department of Defense. So if there's a demand there for rare earths, why isn't the rest of the market also investing in refineries like this? Is it that, frankly, there's just not a lot of profit to be made in the industry, or are they struggling to find people who know how to run these processes? As frankly, particularly when it comes to the heavier rare earths, refining is actually a somewhat complicated process. Why aren't we seeing the free market starting to build their own rare earth refineries at the moment?
It's the combination of both. The knowledge base for refining and separation, as well as the metallization and the magnet production. The knowledge for all of that has slowly deteriorated outside of China. And what little knowledge there was left over from the 90s and early 2000s has migrated towards China. And so you'll have a couple of different research centers outside of China that are dedicated to finding ways, extracting rare earths from other materials like coal. And then in addition to that, a little bit of a couple of research institutions that look at separations. But that's maybe tens of people, maybe 200 people at most. And you would be comparing that to thousands of researchers within China. And so the disparity in the amount of knowledge of the separations process, and when you move that into the commercialization phase, there's even less knowledge there.
Now, if anyone listening at the moment also scrolls around economics Twitter like I do, I'm sure that this rare earth problem isn't new to you. And if you're just reading the headlines, it might actually seem like we're right in the middle of an REE boom. As right now, it seems like almost every single week, I see a new story popping up saying something like massive new REE deposits discovered in Sweden, or new state government project will give this mine $2.2 billion to begin mining REE, which as a headline sounds great and like we're really tackling the issue. But it's not until you start looking into it that you realize that all of this investment and all of these press releases we see almost entirely focus on just one part of the chain, the extraction. As frankly, announcing you found a new mine is pretty much just the same as saying you just stumbled across a new warehouse full of this M&M mix. And what I see far too often is that these press releases don't go into things like what the ratio of Skittles to M&Ms is, or how difficult it might be to get that bucket from the warehouse to where you need to refine it, or what rules that country might impose on any miner looking to work there. And next time you see one of these announcements pop up in your Twitter feed, go read the announcement, because I can almost guarantee it will only ever focus on that very first part of the chain, just extraction. So in reality, a lot of this is still very much up in the air, where we see lots and lots of announcements, but very little groundbreakings. So Fabian, you follow this industry much closer than I do. Why do you think people are making all these big announcements? And what do you think we should be taking away from all of this?
When it comes to announcements of new deposits that might be able to contribute to diversifying supply outside of China, my first question is, what is the concentration and is it economically viable? When you do find one of those that does get targeted for funding, for example, through loans and grants for private sector investment, then the next question becomes, okay, let's say you get through 10 years of local community pushback, stakeholder engagement, and regulatory compliance so that you can open up and begin to produce extracted material. Who are you going to sell it to? The next stage in the supply chain, which is the separations and processing and metallization. And depending on which application, maybe that's magnet manufacturing, maybe that's further production and processing into a YAG, a precursor material. That part of the supply chain for these various applications are also dominated by Chinese producers. So opening up new mines is one piece of the puzzle, but one piece of the puzzle is not the entire picture.
And as you can probably see by now, China's model here has us stuck between a rock and a hard place. As whilst, yes, the US and Australia are putting in huge efforts and a lot of money in an effort to try and increase domestic extraction capacity, there is very little actually being done about the rest of the production chain. Because particularly in Australia, as things stand at the moment, thanks to large government subsidies, REEs are being dug out of the ground in Australia by true blue Aussies. And in this part of the chain, we've actually brought China's control of this part of the industry from what was about 90 to 95% back down to around 63% of the industry. However, the problems, as I said, are further down the chain. Because once we've filled our bucket with that M&M mix, in the case of Australia, we don't do any refining here. In fact, for context, in the entire world, there are only 5 refineries outside of China. And the reason why is that, frankly, these refineries are pretty awful, particularly when it comes to the process for heavy rare earths. As whilst there's different refining processes for light, medium, and heavy rare earths, particularly when it comes to the heavy stuff, the refining process not only takes up an exorbitant amount of power, but also creates dangerous chemicals as off-run and radioactive materials like thorium as a byproduct of the process, which is one of the reasons why so few governments are looking to put their hand up to do refining. But what it means is that right now in a country like Australia, where yes, we dig the rare earths out of the ground, we send some of those rare earths off to Malaysia, as Malaysia has one of those 5 refineries outside of China, and the rest of our extracted rare earths actually quite often end up getting sold to China anyway. But let's ignore all those rare earths we do send to China and just focus on Malaysia for a bit, as Malaysia's made deals with the Australian company Lynas, the same one the DoD works with, in order to build a refinery capable of light and medium rare earths inside Malaysia. And again, whilst this is a good start, as Australia gets to pull rare earths out of the ground, but doesn't have to deal with the radioactive waste, this deal between Australia and Kuala Lumpur does get a bit tenuous from time to time, as from Malaysia's point of view, they are facing increasing domestic pushback on the environmental damage that these refineries do, whilst at the same time facing criticism from the Australian and US governments, as for one, they don't actually refine that much rare earth, being pretty much the largest Western-friendly refinery in the world, but only being responsible for about 8% of global capacity. And of that small 8%, Malaysia also sells a large chunk of that off to China, either through official channels or through a massive black market trade that's currently going on, leaving Australia, Japan, the United States, and a whole bunch of other players to fight over whatever's left of that 8%, whilst China still produces nearly 90% of the refined rare earth market. And this is where the key issue lies, in that all of these countries are putting in massive efforts to build more and more extraction capacity, but we're then sending all of this extra rare earth that we did mine mostly straight off to China for refinement and component creation anyway. So what do we actually do to solve this issue? Is there any silver bullet we can use to actually try and tackle this?
I don't think it's a silver bullet solution. It's a multidimensional problem. It's a workforce and institutional knowledge issue. It is a regulatory issue that includes not just the storage of radioactive material and handling and transportation thereof, but also of very long permitting process. And even that in and of itself is multidimensional. On top of that, you have all of the overcapacity that Chinese facilities can produce an extraordinary amount of material that then impacts prices. The fact that these materials are not high volume materials is also an issue. One piece of legislation or one mine that opens up and one grant is not going to solve each one of these issues. That's what makes critical minerals generally a complicated problem set.
When you speak with mining companies about this issue, they will happily admit that there's problems further down the chain when it comes to rare earths. But one of the grievances I've seen quite a lot online, and one of the biggest reasons given for not establishing refineries here in Western countries, is red tape and government regulation. So let's take a minute here and just unpack that for a second. Now, if I were to refine rare earths here in Australia, or expand on the refinery that's starting up in Texas, this would not only require a whole bunch of specialized equipment, but does also cause a whole series of environmental problems as well. Now, if the refining is done in a country like Australia or the US, you end up having to add the cost of cleaning up the radioactive materials, transporting them somewhere safe, storing them somewhere for a very, very long time, as well as paying for all of your staff to have that extra training that's required, each one of which adds to your bottom line and your cost of production. Whereas, in contrast, in China, the regulations are somewhat more relaxed, and quite often this stuff is just dumped in a hole somewhere, which again just exacerbates the price differences between the West and China. But on the other hand, in a country like Australia, if there were no safety catches, it would almost certainly become a massive hot-button political issue, and a race to see which candidate could weaponize it first to try and get re-elected. So whilst we do hear these calls from the industry, that if Australia wants to do more refining domestically, that they need to cut and do away with all these regulations and allow companies operating here to dump the excess waste wherever they feel like, I get the feeling it may not be the solution to the problem here, even though some of us might have loved to see if we could create an animal even more weird than the platypus. But what are your thoughts? When you hear members of the private sector calling for less regulation or the lowering of safety standards when it comes to REEs, do you believe their calls that it will solve the problem here?
I don't think deregulating is the answer here. Regulations and permitting issues, that's one piece. The other side of it is largely the ambiguity and the lack of transparency in the actual price structure behind the material that's produced outside of Chinese state-owned enterprises. Because when it comes to a complex market with geopolitical and strategic competitors that dominate these markets, making decisions and conducting actions that limit the ability of other folks to enter the market, then you can't leave it up to free market principles, because that's how we got here in the first place.
And all of these efforts we've been making to try and dislodge China's position in the rare earth market, particularly in these later parts of the chain, what impact has it actually had on Beijing's grip on the industry?
To be honest, nothing, right? They still have this oversized presence in the market. Even though they have lost market share down from almost 97% of extracted material by the late 90s and early 2000s, that has dropped down. But when it comes to refining of these heavy rare earths, that's 100%. When it comes to the processing of material, they can act as a monopolist actor, because who else are you going to sell it to, right? And until there's new processing for heavy rare earths, as well as new capacity for metallization and magnet production outside of China, that monopolist actor is going to continue to be able to leverage its place in the market to influence prices that affects new companies from entering the market. And this is an area where subsidies and grants and a lot of private equity is needed.
Which brings us nicely to the next bit of bad news, in which making magnets outside of China also just became much more difficult, with China announcing just earlier this year that Beijing is placing a ban on the export of all technologies used in the making of rare earth magnets, both in the civilian and defense application sectors, making it much more difficult for other countries to pick up and start developing magnets of their own. So what impact do you think this is likely to have on the industry going forward?
China dominates the production of these magnets that are used in these applications for electric motors, as actuators, and a variety of other different things. So there's two levels of magnet. There's the lower level magnet that is fine for sticking a photo on your refrigerator, but that is the different type of magnet than what is needed to move an electric vehicle or to actuate a wing on a F-35 fighter jet. The reality is that there's nowhere else to buy it from. There are efforts to try to establish the ability to metallize a rare earth concentrate, a rare earth separated product. There are efforts to increase the magnet production capability outside of China, but they are not yet established. So if you pulled the lever and stopped all exports outside of China or stopped all imports into the United States, there are currently no other options. And until there are, you kind of have to play ball and realize that you are operating in an environment where you could lose access to these materials, as well as their downstream components they feed into.
So, very quickly, we can begin to see where the crux of this problem lies, and why multiple governments are beginning to wake up to just how dangerous and precarious our current rare earth supply chain is. But whilst everyone can agree that it's a problem, very little can actually agree on what the solution should be, or whether we should be leaving this to governments to solve, fighting government intervention against China's government intervention, or whether we should leave this to the free market to solve. As a lot of governments aren't really interested in entering a who can lose the most money fight with China anytime soon. But if we do go down that road of government intervention, what options do they actually have open to them? Well, to answer that, we turn to our second guest.
Part 2. Sovereignty through supply.
The mining industry has something in common with oil and gas, and that is these investments, you have to be able to imagine a 20-year future for a project before it will fully pay for itself. So when thinking about these projects, mining companies, whether they are parastatal or whether they are purely private, have to really think about the 20, 30-year future of what they're doing.
Teresa Sabonis Health is the chair of the Science, Technology and International Affairs Department at Georgetown University. Prior to joining Georgetown, she was also a professor of national security strategy at the National War College and is an expert in the development of national security strategies, having assisted in the development of two of the former USSR states' national security and energy policy strategies. So we're thrilled to have her back on the program today.
I think the direction we're moving is thinking seriously about stockpiles. Bear in mind that rare earth minerals are not continuously consumed. So let's say we need lithium for lithium batteries. But if you suddenly halt the supply of lithium, it's not like halting suddenly the supply of oil or gas, because the industries are not consuming those minerals constantly. So what we did in an earlier era back in the 1980s, when we felt that the Soviet Union was able to manipulate markets and things that were strategically important, is the US government identified a small number of materials that were designated as strategically sensitive, and we had carefully monitored stockpiles. And the assumption of those stockpiles was that interruptions of more than 6 months were unlikely. I think that's the direction we're probably going to begin moving with these strategic materials because it is so difficult. The other thing to keep in mind is it's not that democratic countries have no strategic minerals. These minerals are extraordinarily destructive and have a lot of downstream consequences, and authoritarian governments are better poised to ignore the damage done to populations or the will of the population. What we find is that sparsely populated democratic countries like Canada or Australia have better luck with this. And that's why a lot of people are beginning to talk about mining the deep seabed, because again, where could you mine without immediately disturbing populations or having major pushback in democracies? Of course, deep seabed mining is problematic for many other follow-on reasons, but the temptation that some nations are experiencing, including the US, to go in that direction come from this inherent mineral disadvantage that countries which care about their populations are faced.
So I know you've done a lot of work with the nuclear industry over the years as well. So I thought I'd harness that background as well, as that industry, particularly in the early days, also faced a lot of the issues that the rare earth industry is currently going through now. As, let's say, if we look at your previous point around stockpiling or government intervention into the industry, both of those are going to have very different impacts on the private markets. As whilst the government buying a huge stockpile to prepare for war will inject a whole bunch of money into the industry and will increase demand for the product at home, that increase in demand is also almost certainly temporary, as once the government stockpiles are full, the demand is likely to return to normal, which is not really great looking at the feasibility of a 30-year investment into a mine. But what about minimum guaranteed purchases by the government? In much the same way the government did that for the uranium industry back in the 1950s and 60s, where the government would guarantee these companies that they would buy a constant amount of power or uranium from these companies, giving those private investors a pretty solid peace of mind that there was a guaranteed income coming in going forward, which is something that's very important in an industry like rare earths, where most mines expect to be losing money for the first decade or so. So in your opinion, do long-term government guaranteed purchases actually solve the issue we're facing here?
So it depends on how you do it. I think the best way for me to explain this for you is let's think about small modular reactors.
And just to insert some context here, an SMR, small modular reactors, being miniaturized nuclear power plants that can be purchased for much cheaper than a full plant and inserted into a city as a mini nuclear plant, a concept that is being worked on and researched for a very long time, but has always struggled to find economic viability.
The United States is hoping to move into this small modular reactor space. The Nuclear Regulatory Commission has approved small modular reactors. A few of them are being built. But these reactors all use a fuel called HALEU, high-assay low-enriched uranium. It's enriched to 19.5%. And the recipe for each of these experimental reactors is slightly different, which is very unfortunate. The industry is telling the U.S. government that a guaranteed purchase of a minimum volume is necessary, or building SMRs is always going to be handicapped by the unpredictability of the fuel. The potential producers of the fuel say, yeah, we need somebody to guarantee how much you're going to purchase because the scale on which we build this depends entirely on what we think the market is. Meanwhile, all the way up until a few months ago, the only source of HALEU fuel for the United States was Russia. So there was huge pressure to come up with the alternate strategy. And initially, money was set aside, several billion, but the industry said that's not sufficient. We need to have some guaranteed minimum purchase to build this new equipment. If you're trying to make an investment to go into this and you have no idea how many reactors are likely to create this demand, the upfront costs are so extraordinary that no one's willing to do it. These are investments in the billions for a very specific niche fuel that can only be used in a very specific, highly regulated way. So the argument is we've got to get more predictability of quantity before we can produce this at any price that makes it possible to start up this new industry.
And it probably also should be pointed out that the rare earth industry also has a whole bunch of extra complications to add into this as well. One of which being that unlike nuclear power, where power demands for a city is much more predictable over the long term, and both the public and private consumer markets are pretty much forced to use whatever power company is providing power to that city. When it comes to rare earths, that market is far less predictable, as whilst the public sector demand for rare earths is mostly the Department of Defense and the Department of Energy, the amount those guys need is nowhere near enough to keep the industry afloat by themselves. And if we look at the private sector, unlike the nuclear power industry, where there is a captive audience, the private sector can simply go wherever the price is cheapest for their REEs, meaning getting magnets purchased in China, meaning that if the government were to adopt a guaranteed purchase strategy, much in the same way they did with nuclear power, they'd either be forced to sell their rare earths into the private market with a massive subsidy just to stay competitive with what China's offering, or otherwise put their rare earths into the market at the price in which they produce them and watch themselves be far higher than what the Chinese can produce, meaning that their entire customer base is pretty much just going to be the Department of Defense. So either way, a massive bill for the government, and it doesn't really solve the problem. So maybe we should look to the private industry and see if the problem can be solved over there. And for that, I want to shift into the perspective of a private mining firm looking to start up a rare earth mine. So we can look at some of the challenges those guys are going to be faced on their front. The big point you need to realize going into the world of private power generation or private mining is that the industry can actually be quite scary. And what a lot of people may not realize is that for the private company starting a mine, even in the case it's a fairly easy mineral to extract like gold or copper, the financial risks are still incredibly high. As once a company commits to a mining project, they then have to start building that mine site up, which means not only building the facilities, the transportation corridors, probably doing upgrades to local infrastructure, housing and feeding all of the staff as they build it, and probably paying top dollar to get it done as quick as possible, the bills quickly rack up. And whilst those bills are already terrifying, you then need to think about the fact that these mining companies probably had to take out a large loan, which for REE could be somewhere in the vicinity of $1 billion. And these companies could be paying something like 8 or 10% interest on those loans they took out. So if it takes 2 years to establish, they're not only not making any money on the mine, but they're also paying all these expenses out and the interest on top of that. So for a private mining company, there's a lot on the line starting up a rare earth mine. And again, this is an industry that is far more volatile than others, with even some of the bigger names in rare earth production like Molycorp or Mountain Pass having gone bankrupt in the past. And the industry's current golden boy, Lynas, getting really close to bankruptcy on a few occasions. Again, it's a tough field to cut. And for a new private company to enter the market, they're going to have to expect to not only pay to establish a mine and pay to establish a refinery, but also lose a whole bunch of money while they do it. And unlike gold or copper, the demand for the final product may not be as guaranteed. But before we move on to some of those later phases in this, can we take a look at the first early phase of mine establishment for the private industry? Can you take us through the power dynamic between a company looking to establish a mine or a refinery in another country versus the local government then overseeing that contract, giving us an idea of some of the factors that will be impacting a private company's decision on whether or not to invest into a private REE mine or private REE refinery?
Absolutely. In fact, if you look at the outset, the industry has all the power because they have the technology, they have the know-how, and they have multiple possible venues. Once the industry has sunk cost, the balance of power begins to shift toward the nation. And once the nation has enhanced know-how, then the nation has greater power. So an optimal corporate structure is one that makes sure that over a 30-year period, more and more profit goes to the country. If you look at what was done in Azerbaijan, essentially what they did was for the first 10 years, almost all the profits went back to BP, and BP recaptured its cost of investment. And then in the subsequent 10 years, it was much more of a 50-50. And then by the time we got into the third decade, there were more and more benefits to Azerbaijan. So the industry really has to think about and incorporate the costs of this obsolescing bargain problem.
Okay, but how guaranteed are those contracts? If I'm working with a government who, let's say, isn't particularly stable, but I have a 30-year deal with that government, in reality, how guaranteed is my contract?
Well-designed contracts reduce the incentive for countries to become mischievous or capricious, but that doesn't guarantee that they won't.
Now, as we went through earlier on, unlike an oil or gas refinery, a rare earth refinery comes with a lot more serious environmental problems, including the production of nuclear thorium waste. Now, if I'm an Australian company, it means I probably can't establish this refinery in my home country, not only due to the environmental regulations and the almost inevitable political pushback my project is going to get, pushback that could possibly shut me down before I reach my profitable period, but also the fact that whilst Australia has guaranteed contract law, and I have a pretty high degree of confidence that a 30-year contract will still be valid in 30 years, it also comes with much higher labour costs, much higher electricity costs, and much higher transport costs, all of which are likely to make my rare earth mine nowhere near competitive on a global market. Again, because I'm competing with China here. Which means pretty much my only option then is to go establish my refinery or my mine in another country, one that probably has lower environmental standards, lower cost of labour, and lower regulations. But establishing myself in a mine like that also comes with a whole other set of risks as well, as if I were to go do this and take on that $1 billion loan and then lose money for the first few years getting it all up and running, if I've established my mine in some sort of third world dictatorship, what prevents that dictator or the host country then simply gouging me once I've sunk my costs in, doing things like upping license fees or charging massive entry fees every time I bring anything in and out of the port, just attempting to gouge away my profits in any way they can, knowing that I can't just pick up my mine and move it somewhere else?
So not only do the mines have to worry about that problem, the mines also have to worry about the problem that in other countries, those ores may be closer to the surface, they may be richer in quality. Namibia has lost huge market share to Kazakhstan, even though the government of Namibia really wants to do a lot of mining, simply because extraction in Namibia is so much more expensive than Kazakhstan. So the uncertainties for this mining are pretty overwhelming. If you have global markets available, you're not only worried that the government might change its rules and regulations, you're worried that quality and price of extraction may be fundamentally different in a different location.
Okay, so what about a worst case scenario where the incredibly weak government I chose to work with, because frankly they were happy to take the 107,000 USD and look the other way when I dump my thorium waste into a cave somewhere in the mountains, what happens when that government inevitably gets overthrown, or even just simply turns against me, and the new administration I'm working with chooses to simply seize my mine for the people? A mine that I remind people I'm stuck paying the interest on regardless. As a mine owner, what sort of recourse or protections would I have against that kind of thing?
You actually have very limited recourse, even under the WTO, as long as compensation is paid and as long as nationalization follows along a certain set of prescribed directions. The WTO does, to some extent, protect the capacity of nations to nationalize mines. So you're absolutely right to consider the fact that some of the history that extractive industries have had in the region makes the industries themselves a little bit cautious.
Well, I guess I'll do my best to look thrilled when they offer me $10,000 and a plane ride back to Paris in exchange for my mine. But what I think we can take away from this is that, as you can see, the private industry has to find a country that has not only cheap labor, but also a stable enough power grid, and a power grid capable of handling the massive amount of power required for rare earth refining. They need to have local expertise in technical refining, so having a pre-existing industry and a similar product is also going to be pretty important, as I'm almost certainly going to have to bring locals into the project. The country also has to have little to no environmental regulations, access to global shipping lanes so that my goods can't be embargoed very easily during a war, and probably does enough trade with the international community to make it less likely that they'll just seize my mine and scare away all the other ones. On top of that, I'm probably also going to look for a country that does have a pre-existing and well-established manufacturing base already existing within the borders. So that way I can try and avoid some costs and tariffs I'm likely to incur if I try and ship my rare earths to a third country for refining or component creation. And with that checklist, I think we can pretty easily see why, as a private investor, I would be pretty quickly arriving at either China or Malaysia, making it somewhat unlikely that, left to their own devices, the private industry will be able to solve this problem on their own. So government programs have their difficulties, the private industry has difficulties, but what if we flip the script and go the other way with it? What happens if a developed nation were to instead pursue a policy of something like government nationalization? That Biden comes into his office tomorrow and says, bugger it, we're already paying a huge amount in subsidies and paying most of the bills for the refineries operating within the US. Let's just send in the army and seize it for ourselves and have the US government run this rare earth refinery. Does that solve the problem we're facing here?
So frankly, every oil and gas company over the past 50 years has actually built into their long-term planning and long-term fears the possibility of nationalization. It is conceivably possible. But even if you nationalized, think about the problems that you're trying to address. You're having to address the impact to the population, and you're still going to have to provide for mitigating those downstream impacts. But you're also going to have to deal with the fact that geology is inherently unfair. What if the U.S. does nationalize? What if the U.S. does decide it's willing to strip mine native lands for uranium? And yet we're moving into an era of geoeconomics. We've traded so vigorously and with such enthusiasm for so long. We're having a hard time thinking about how do you incorporate the prices and strategies of national security interests. And I would posit that between doing nothing and nationalizing, there are a lot of ways that governments can engage in these markets, incorporate some strategic considerations without having to actually take over these markets.
So for now, I think we're starting to see some of the cracks. That for the private sector operating here in the West, the rare earth industry is kind of a nightmare, where the costs are high and the risks of regulatory pushback are high, the difficulty to extract this stuff is high, the demand isn't constant, and even if you get massive subsidies and guarantees from the government of the day, can you be absolutely certain that some future administration, either 5, 10, or 15 years down the track, won't simply tear up that contract, particularly if it's costing the government quite a lot of money? And for the private sector, you have to take on all of this, knowing that at any moment, China could simply just drop the price and undercut everyone in the market, just like they did back in the 1980s, which for you and your board of shareholders would likely mean bankruptcy. So what about governments? They all know they need to do something, but what can they do? Well, there are still a few options left on the table for us to talk about. And to take us through those options, we turn to our final guest.
Part 3. The Hollowing Hegemony.
There are 200 different minerals that contained rare earths, and some of them have military applications, some of them have transportation and renewable energy applications. And for example, the lighter rare earths like cerium in connection with phosphorus can be used in water purifiers. Lanthanum is used as a hydrogen absorber in rechargeable batteries. Praseodymium is used in alloys with magnesium to build aircraft engines. For heavier rare earths, dysprosium oxide is used to cool fuel rods in nuclear reactors. Terbium is used in solid-state drives for data storage, a critical technology across various industries, and they all are used in defense applications. So let me tell you, without it, modern technology, our green transition, and defense applications will not happen. And this is why it's so important that the West collectively, US, Europe, Japan, Australia, all have their own supply chain and are not dependent on our Chinese friends.
Ariel Cohen is the Managing Director of the Energy, Growth and Security Program at the International Tax and Investment Center, who, in addition to that, is also a Senior Fellow at the Atlantic Council. Prior to that position, though, Ariel spent 20 years at the Heritage Foundation as the Senior Research Fellow in the Russia and Eurasia Studies and International Energy Policy programs, directed Heritage's war games, and worked closely with members of Congress and congressional staff members to help craft national security and energy policy. So we're thrilled to have him on the program today.
So you see that China is still occupying a disproportionately large and strategic position across the board, upstream, midstream, downstream. China will not hesitate to impose sanctions or to cut supply, as they did in 2009 and then again in 2023.
So having looked at a lot of your previous work, you've referred to this issue as a national security issue. And for me, I very much agree with you on that one. I think it's going to be pretty hard to ask China for europium or yttrium for our F-35s if they're also trying to shoot those down at the same time. So if this is a national security issue, how do we beat China in this theater?
It's a very important question. It's important on the level of how America conducts business in the fierce competition with China, but it's even more important in terms of national security. We need steady production, and we need to take back this whole supply chain. We need to build it. It doesn't exist yet, but we need to build it. And I'm afraid, honestly, that we don't have the time. The clouds are gathering both in Europe with Russia, as well as in the Pacific, in the South China Sea and Taiwan. And we don't have the time to build the supply chain. So by hook or by crook, we need to build it, be it here in the United States, maybe in Canada and Mexico, and some amount with our allies in Europe and Australia.
One of the suggestions that's been floated quite a lot is one where the US returns to its Cold War playbook and starts buying up large stockpiles of these rare earths to put aside for a rainy day. What are your thoughts on pursuing something like that as a strategy?
We absolutely should stockpile, but the Chinese are not stupid. If they see us starting to stockpile, they'll start squelching. They already did it. They did it with Japan as a punishment for Ryukyu Islands conflict. So if we stockpile, the Chinese will drive the prices up, make it more expensive, or kill the supply altogether because they understand the strategic implications of such a supply. But we have no choice. We need to build the stockpile.
And I'd be shocked if the US aren't doing that already through third-party countries or harnessing some of the black market minerals that exist. But the big conventional talk of the town, the big strategy the US seem to be pursuing, is the one Biden proposed just a few years ago, with the centerpiece of this strategy being Washington's massive investment into building rare earths here in the United States, as well as looking to boost support for rare earth production in allied countries like Australia and South Korea. But with the private sector still being consistently undercut by China, and the public sector probably not possessing enough demand to facilitate the desired level of production within the United States organically, how do we foster a long-term, robust domestic rare earth industry?
When we manufacture in the US, it has its good side, its bad side. The Biden administration and the Trump administration before it pretty much remained on the same track of reshoring, friendshoring, bringing back the more sensitive technologies from China, and sometimes not just sensitive technologies. Look, if I bought an EV that is made in China and pay $10,000 less, as a consumer, I win. But as an American, knowing that these jobs left Detroit or Alabama and went to China, I understand what's going on.
Now, as a part of these programs put in place by the Biden administration, most purchases by US companies working with the government, but especially the Department of Defense, will be forced to buy all of their rare earths from the United States or one of its selected allies once these refineries are up and running, which on the surface makes sense because it drives domestic demand and makes sure that the supply chain stays on home soil. However, there are underlying concerns with this strategy as well, as if you go one way with it and you make it absolutely airtight and really bring the hammer down on any company breaking those rules, then you can very quickly reach a point where if the demand for military equipment surges, but the rare earth refineries can't surge to meet that additional demand by the same rate, if not more, what you've then done is introduce an artificial bottleneck into the domestic production chain, where rather than being able to just buy up other countries' stockpiles at a higher price to facilitate any possible required surge in production you might have, under that system, you don't have that as an option. So potentially you could end up in a situation where you have the entire US war effort waiting on just a single refinery, which again, not great. But if you go the other way with the rules and make the restrictions around this one quite weak, in other words, pretty much what the restrictions are at the moment, it does open up loopholes that can be easily exploited. So for example, if someone from, let's say, Lockheed Martin is building an F-35, they would 100% be banned from buying rare earths from China, stipulating that they have to buy all of their rare earths from Americans. Again, which sounds reasonable. But with these rules the way they are, someone like Lockheed could also buy those rare earths from any Americans, making it very easy to, let's say, use one of their subcontractors, hire them to buy up a whole bunch of rare earths in China, and then buy the rare earths off that subcontractor, therefore technically meeting the definition of buying rare earths from an American, particularly if they pretend not to know where those rare earths came from in the first place. Now, just because they could buy it through a subcontractor doesn't necessarily mean they will, but they are also a private company. And if they were looking to save some money, well, under the current rules, that option's always there. So you think that under a system like the one that's coming into place, there is still a risk of companies, whether they're in the US or not, using loopholes like that to circumvent some of these restrictions that try to curb the Chinese rare earth industry?
Oh, absolutely. For example, with the Russia sanctions now, countries make money by buying American microchips and then reselling them to Russia. So what you just described can happen.
And seeing as people are getting away with selling American microchips to Russian companies, microchips being a somewhat identifiable product, it becomes even easier to smuggle rare commodities. As while one microchip is almost always different to another, a kilo of neodymium produced in the United States, by definition, is almost exactly the same as a kilo of pure neodymium produced within China, especially if they're ever melted down and re-stamped with US markings, making the smuggling of rare earths even easier to do than microchips, which, if that is the case, how do you combat an issue like this?
You regulate. That's why we have a bloated bureaucracy in the US government, including in the Pentagon. We can procure from the global market in the security space, and other things we have to build the domestic or friend-shoring supply chain, be it Canada, Mexico, Australia, or somewhere in Europe.
Now, one of the options also consistently put forward to be able to build that domestic manufacturing base, whilst still utilizing the free market, is through the US subsidizing domestic rare earth production and refining to a point where it's economically competitive with the Chinese, and thereby driving demand back toward the US. As whilst most of the private sector will go to China when it's cheaper, if the US market goes cheaper, or even just a slight bit over China, there's a good chance that a lot of them will pull their manufacturing back toward the United States. Although I'm also pretty sure you won't get everyone, as right now China does offer the convenience of top-to-tail manufacturing supply chains in this area. Regardless of that, what are your thoughts on using subsidies in order to make the United States rare earth capacity competitive on the world stage?
You don't need subsidies as long as you have a steady policy of ordering these supplies and paying for them. If you know that you have a 10-year contract with Department of Defense or Department of Energy or with a large manufacturer like Tesla, you do not need subsidy and you do not need nationalization. You don't need the government to run it. The only sector that I can think of where the government is 100% active is uranium enrichment. And yes, in enrichment, the US government is processing it because it also has weapons applications. Everything else, including mining, there are private companies, and this is the American way. This is how we do business, in which the government provides long-term contracts and floats that industry as they float defense industry. Without government contracts, Boeing, Lockheed Martin, Raytheon would not exist.
Well, even if we look to the private sector to try and solve this problem, do you think there is something the government could be doing to try and improve the situation?
I think what the government should be doing is mandating non-China procurement, and we're doing it already. You cannot depend on China when you're making your F-35s or you're making your rockets and missiles. In the civilian applications, if you're making solar batteries or magnets for windmills, you can go to the market. But for defense applications, for sure, for nuclear reactors, for components of weapon systems today that are extremely computerized, all this sophisticated electronic production requires rare earths. For military applications, I am adamant that we have to protect our supply chain with contracts, not necessarily with nationalization. And you keep calling it subsidies. I just call it contracts.
In which case, what's stopping the government from just doing that tomorrow?
Like everything else, it's a matter of money and political will. I would put some real heavy hitters because the president can do only so far. There's so many hours in a day, but we need a rare earth czar to build the supply chain. Roosevelt used to do it very effectively in World War II. But of course, we need to put billions of dollars, maybe tens of billions, because all this is very capital intensive. Expenditure is huge. I was looking at the Swedish discovery. They discovered a big deposit, and it will take 15 years and billions of dollars, if they can find it, or euros, to develop it. We need to allocate these resources now.
If you sat down and asked me to give a summary of the last 3 years in rare earths, personally, I think our situation is actually a little bit better than what it was back then, because we are seeing countries ramping up their friendshoring. We are seeing US domestic refineries finally reopen, and we are beginning to see countries stockpiling rare earths. It's also a pretty positive sign that at almost every bilateral or multilateral summit these days, the issue of critical minerals and supply chains will almost always come up. And whilst I'm happy to see all of that, have we actually solved this issue? Not at all. In fact, from what it seems, all we've done is claw back about 30% of the market in just the very first part of the production chain. In fact, some would argue it's possibly even worse, as China is now aggressively consolidating its own domestic market and wielding an increasingly tight grip on the refining technology that got them to where they are today. And whilst the US and other theatres has dealt some serious blows to China, particularly in things like microchips, when it comes to rare earths, there's a few unique properties that give China a bit of an advantage. As whilst on the chip issue, when push comes to shove, people will almost always pick the US or Taiwanese chip over the Chinese one. When it comes to rare earths, a kilogram of neodymium, whether it's made in the US or China, is pretty much exactly the same. The only major difference being the price and its proximity to the rest of your supply chain, both of which are probably advantages to Beijing. And this is a pretty serious concern for the US, because as things currently stand, China has a pretty good response regardless of which direction the US goes with it. As an example, if the US decides to try and rapidly build a stockpile, China can simply yank up the world price or even attempt to cut the US off. If the US are successful in building a domestic manufacturing base for these things, well, China still has its playbook from the 80s and 90s, and still very much maintains the capabilities to simply lower the price to a level to send all of these new US companies into very rapid financial distress. And if China goes down that road, much like they did in the past, the US once again is stuck between a couple of bad choices. To either let all of these new companies go bankrupt, or be stuck with a massive bill continuously subsidizing these products to be artificially competitive against China, all of which is pretty likely to make long-term investors somewhat nervous about the industry. This issue here, around rare earths, is going to be a serious fight for the US. And unfortunately, it's a fight that the US economic system was really not designed to fight. Thank you so much for checking out the show this week. It is great to be back after we'd just taken the very first 2-week break in the show's nearly 5-year history. And I want to give a very special thank you to that handful of people who either reached out directly to myself or members of the team, whose first assumption upon not seeing an episode was that I was either dead or kidnapped somewhere overseas. Your faith in the consistency of our schedule is somewhat heartwarming, but I am okay and thanks for reaching out. However, in future, if you do want to be one of the first to know when I do inevitably get kidnapped, you'll be able to find all of the information and links on our Twitter, Reddit, Blue Sky, Mastodon, Threads, Instagram, Facebook, Discord, TikTok on the handle @TheRedLinePod. Or if you're keen on following me, I'm on the Twitter handle @MikeYelliotOz. Oz is in Australia. This show can only function with the support of our amazing Patreons, whose donations help us keep the show going. And speaking of our amazing Patreons, this week I'd like to thank Washington 13, Subtle Knife, Paul Petrick, David Faulting, Rashan, Isaac Lewis, Rebecca Barlow, Andrew Moore, Matthew Palmer, Mac Dolly, Metal Dragonar, Jens Nordberg, Dan Baumgartner, and MM, who are the latest patrons to sign up as of the time of recording. This show is only possible with the support of listeners like these guys, and we cannot thank them enough for all of their support of the show. So if you feel you could spare a couple of dollars and want special access to things like our upcoming Patreon events or our recent workshop, giving full analysis and backstories to the 30-odd people closest to Vladimir Putin, you can do so by signing up to our Patreon today and checking out the Patreon-only playlist. As usual, here are 3 book recommendations. The first is The Rare Metals War by friend of the show, Guillaume Petron, for a fantastic insight into this particular issue. The second is The War Below, Lithium, Copper, and the Global Battle to Power Our Lives by Ernst Scheider, for a look at how trade wars in the mining industry often play out. And the third is The Looting Machine by friend of the show, Tom Burgess, for a look at the dirtier side of the mining industry. I want to thank this week's guests, Fabian Villalobos, Teresa Zabonis Health, and Ariel Cohen. All of you were absolutely fantastic to have on this one, and I look forward to having you all back on the show sometime soon. I'd also like to thank the primary researchers of this piece, that being Jamie Tanu, Lorenz van Kierbilk, Nick McNally, Robbie Sutton, Scott Missler-Ferguson, Ben Nutter, and Sean Cotter-Lem. An amazing amount of details on this one. But while their work is incredibly appreciated, they're not the only people that make this team work. So I'd also like to thank Cameron Gale, the producer, Jack Shankman, the production manager, Daniela Juvella, Nate Ostilla, Robbie Sutton, Nick McNally, Jemima Ben-Treath, Ben Nutter, Genevieve Donlan-May, Perry Grace, Gabriel Lane, Lorenz van Kierbilk, Mason Wise, Andrew Gundle, Isaac Gibbs, Scott Missler-Ferguson, and Sean Cotter-Lem, our research assistants and writers, Jamie Tanu, our media director, Raul Devanarayanan, our OSN analyst, Francis Leach, our director of breaking news, Mark Spencer, our second voiceover artist, Kashyap Maheshwari and Alexander Woolgarten from our online team, Jonan Gunn, our production assistant, Alexi Heimakainen, our Discord moderator, Joe Hawthorne, our audio cleaner, Rizza Rafter, our videographer, and Nick Munch, our field correspondent. I've never seen such a hard-working team in the industry, and one any more deserving of a 2-week break. But glad to be back with them, and putting together episodes like this one, which brings us to the end, where I'm happy to say that the Red Line will be back in a fortnight's time, with another international episode. But until then, thank you for listening, and good night.
The views and opinions expressed in this episode are solely those of Michael, our guests, and the Red Line podcast. They do not represent any government or organization and are solely our own. For more information, please visit theredlinepodcast.com.